Welcome to this explainer. Today we're going to completely demystify the core mechanics of Python's object-oriented programming, and we're going to finally make sense of exactly how instances are built. If you've ever stared at Python code and felt, just completely lost in a sea of underscores in the word self, you are in exactly the right place.
It's the exact question that frustrates so many beginners, and honestly developers coming from languages like Java or C#. Why on earth is self literally everywhere in Python? I mean, in other languages, a reference to the current object, usually called this, is just implied, right? But Python forces you to write it out over and over again. Today, we're unpacking exactly why Python does this. And trust me, by the end of this explainer, you're actually going to appreciate the underlying logic.
Here's our roadmap for today. We'll look at the object factory concept, how we initialize with init, the real secret behind self, the difference between class and instance variables, and finally, the notorious mutable variable pitfall. Let's get right into it.
Starting off with Section 1, the object factory concept.
Okay, let's dive into this with what is absolutely the best metaphor for understanding OOP. Think of a class as a factory that creates objects. A class is, well, incredibly narcissistic. It's basically a blueprint or a factory that pumps out unique items, but it is not the actual object itself. As one developer perfectly put it, classes are all about me, me, me. They like to own things and they like to let others do things to them. So when you write a class called person, you aren't creating an actual person. You're building the factory that knows how to create as many unique people as you want, assigning them random memory IDs so the computer can actually keep track of them.
Moving on to Section 2, initializing with init. So once the factory physically builds the object under the hood, we have to set it up. Now, while a different method called new actually creates the instance in memory, init is where the real setup happens. Think of it as a constructor. Whenever you type something like person, parentheses, Alice, this init method runs automatically. It gives Alice her unique starting data, so she isn't just some generic factory clone.
Which brings us to Section 3, the secret of self.
Right, so to set up that unique information, we really have to address the elephant in the room. Why does every single method inside our class need this word self as its very first parameter? Unlike C# or Java, where a reference to this is just implied, Python strongly believes in keeping things explicit. You need to know exactly what is modifying your data. It's actually a core philosophy of the language, famously stated in the Zen of Python. There's no magic background environment here. If a method is going to change an object, that object needs to be explicitly handed to the method. This brilliantly illustrates Python's sleight of hand. Think about how we usually write code, mycar.drive, right? But that is actually just syntactic sugar. Behind the scenes, Python secretly executes something completely different. It calls car.drive and passes in mycar as the argument. It takes the specific instance you're calling the method on and literally shoves it in as the very first argument.
Because Python passes the instance itself into the method automatically, well, we have to catch it. We need a placeholder in our method definition to accept that incoming object. So we conventionally call that first parameter self. It binds the specific data to that specific memory ID. And here's a fun little fact, self is not a protected keyword. You could technically name it this, or apple, or my_object, but please, for the sake of literally everyone reading your code, stick to self. It is a universally accepted convention for a reason.
Let's jump to Section 4, class versus instance variables. Let's see exactly how self builds a strict boundary between what belongs to the factory and what belongs to the product. There is a huge divide in Python OOP. Class variables are defined directly in the class body. Think classname.var. These are your factory defaults shared by everyone. Instance variables, however, are defined inside methods like init using self.var. This means they belong strictly to the individual object. If you change an instance variable, it only affects that one specific object.
But how does Python actually know which one to use if they share a name?
Well, when you try to read a variable using dot notation, Python executes a very specific chronological lookup order. It looks at the instance's private dictionary first. If it finds the variable there, boom, it uses it. If it doesn't find it, it falls back to the class namespace. This lookup order guarantees that an instance attribute will absolutely always take priority over a class attribute of the same name.
And that brings us to our final part, Section 5, the mutable variable pitfall.
Misunderstanding this shared state leads to what is arguably one of the most notorious bugs in Python object-oriented programming. Imagine you write followers equals an empty list right at the top of your class body.
totally outside of init. You might think you're just setting a nice, clean default state for every new user you create. Makes sense, right?
Wrong. Here is where disaster strikes. Because that mutable list is owned by the factory, the class itself, it is shared across every single product that factory makes. So if user A gets a new follower and appends it to the list, and then user B gets a new follower and appends it to their list, both users will suddenly show as having 2 followers. Mutating it from one single instance tragically alters it for every other instance in existence. It's a total mess.
The only correct fix here is to write self.followers equals empty list inside your init method. By attaching it to self, you're explicitly telling Python, hey, do not use a shared factory list. Go into this specific object's memory space and give it its own fresh, isolated copy of an empty list. Problem solved.
I want you to go look at your own code right now. Seriously, open up a project right after this explainer. If you have lists or dictionaries sitting at the class level, ask yourself, are they truly meant to be shared constants across every single instance? Or is it time to move them into init before they cause a massive bug? Once you master self, you really do master Python's memory. But it does make you wonder, what other magic is Python secretly doing behind your back every time you hit run?